Hello, good day viewers. The title of this tutorial is Understanding System of Equations. And I promise you, even the small child in kindergarten will understand what a system of equation is all about. And we're going to use linear system of equation in this tutorial. Let's start with something very simple, that is equation. When we say equation, we're talking about a system where the left and the right hand side are exactly the same. This is why we use that equality sign. And the best way to explain an equation is by the use of scale. If I should have a scale like this, you know what a scale is all about. This is a scale. You know that definitely if I should add something here, it will go down, right? And if I should move it, it will go back to its equilibrium position. If I add something here, it will go down again. If I add the same quantity to the other side, it will remain at equilibrium. So this position tells us that the left and the right hand side are exactly the same. This is why these two pans are on equilibrium position. Let me use numerical expression. For example, 2 together with 3. This will give us 5. This is an equality sign which shows the left and the right hand side have the same magnitude. That's fine, we have 2 and 3 here, but the combination of 2 and 3 will give us 5. What if we decide to remove this and put a box? You know, this is what we call an open sentence. 2 plus a certain number, which is unknown, is 5. So what is that number? It is definitely 3. So we can say that 2 plus x. This is why we always use x, y, z variables. We call this one an unknown variable, x. 2 plus x equal to 5. We know that x must be equal to 3. And since x is strictly equal to 3, we say that this equation has only one solution. But in some certain instances, we may have an equation with infinitely many solutions. For example, if I should remove this 2 and replace it with a box plus x equal to 5, this is another open sentence, but I can confidently remove this box and replace it with y. So we are saying that the combination of y and x will give us 5. So what will be the value of x and y? In our first equation, we have seen that x must be equal to 3. But that is not the same in this second equation. Yes, x can be 3, y equal to 2, and the equation will be true. But y can also be equal to 3 as well as x equal to 2, and the equation will remain the same. So you can see that we can have a lot of combination of x and y that can make this statement true. Let's find some of the solutions. For example, we may have 2 plus 3. This is true. This must give us 5. We may have 3 plus 2. This must give us 5. And this x may decide to be negative because it is unknown. We don't know what it is. It could be positive or negative. So this can be 7 minus 2. And this remains equal to 5, which means that x here is negative 2, while y is 7. A lot of infinitely many combination of these numbers that can give us 5. And we decide to use 195. That is when x is negative 95 and y is positive 100. It will still going to give us 5. A lot of these combinations. But wait, what if we have two sets of equations? For example, previously I told you that this has infinitely many solutions because you may have different combination of numbers that can give us 5. But what if we form another one? Let me say this is equal to 5x minus y should be equal to 2, for example. If you consider this one separately, it has many, infinitely many solutions. Likewise, the other one. But in system of equation, we only need that single pair that will work on this at the same time on the other. If I say 3 plus 2, this is equal to 5. If I say 3 plus 2 plus 3, this is the same thing as 5 again. We may choose negative 2 plus 7. This is 5. We have a lot of them. I told you, infinitely many. So in this case, x is 3, y is 2. X is 2, y is 3. X is negative 2, y is 7. That will give us 5. But to solve a system of equation, we only need a single pair that will work here at the same time here. So do you think if I should use 3 and 2, will it satisfy this equation? Look at it. If x is 3, I have 3 here. Because of this minus, you have to use minus. Y is 2. Will this give us okay, let me use 3 here. 1, sorry, let me use 1 here for simple clarification. We know that 3 minus 2 will give us 1. What if I should take this combination, 2 minus 3, this will give us negative 1. If I should use this negative 2, but you know, since we have plus here, this is why I use plus here. But because we have minus here, I have to use minus 7, and this will give us minus 9. We have a lot of them. But it is only 3 and 2 that will satisfy the two equations simultaneously. This is why we call it simultaneous linear equations. In another one, system of equations. So you see that when x is 3, y is equal to 2, this is the only combination that will work here and here simultaneously. We have a lot of numbers here that can make this statement true. For example, if I should take 5 minus 4, this will give us 1. 9 minus 8, this is 1. A lot of them. But you see that the only place where we have similar values is here and here, right? Forget about this minus sign. I pick it from here. I may decide to say minus plus 2, right? So that you can clearly see that y is plus 2. Same thing here. This minus is from this one. This plus is also from this. So when you have an equation, a single equation that contains two unknown variables, like x and y, they are two unknown variables, you must obtain an infinitely many solutions. But if you have two systems, we have two unknown variables here, we have another two unknown variables here. So in that case, you have to get a unique solution. This particular equation has infinitely many, this one too, but among the set of solutions, you must have that pair that will work here and at the same time to the other one. And that pair is said to be the solution to the system. This tutorial is not about how to solve a system of equation. I am just explaining why the system of equation. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.